Dear students, now we can learn about the electrical circuit, that to DC electrical circuits. In that, resistances, if they are connected in series, how to evaluate it, the total resistance. Assuming that here three resistances like R1, R2, R3 are connected in series across the common source. The speciality of the series circuit is here current will be remaining same. The current which is coming from the source will be passing equally through all the resistances. Suppose that you are leaving 2 ampere here, the same 2 ampere will be equally passing through R1, R2, R3, irrespective of the values of their resistances. So that's why it is taken here I is equal to I1 equal to I2 equal to I3. But voltage will be dividing into three resistances. Irrespective of their voltages, the voltages will, irrespective of their resistances, the voltage will be also defined. Depending upon the value of the resistance R1, R2, R3, the magnitude of the voltage drop will be differing. So that's why the algebraic sum of the voltages drop across each resistance will be equal to the total supply voltage, that is V is equal to V1 plus V2 plus V3. You can. Just now we have learned in lesson number 3, according to Ohm's law, V is equal to I into R. Then you can substitute this notation in this equation, so that is V is equal to I into R, then V1 should be equal to I1 into R1. But I1 is equal to I, therefore you can write I into R1. Similarly, plus I into R2 plus I into R3. Now you can take I common from both the sides. They will be cancelling out each other. You will get R is equal to R1 plus R2 plus R3 plus dash dash up to Rn. If n number of resistances you are connected in series, the total resistance R will be equal to that one. It means the total resistance of the circuit when the n number of resistances are connected in series can be calculated by using this formula. Now we can discuss about resistances connected in parallel. Resistances in parallel. So draw the circuit containing three resistances connected in parallel like this. Across the common source of supply, say R1, R2 and R3, the supply current is I, returning current is also I, here the voltage. Assuming that I1 is flowing through R1, I2 through R2, I3 through R3. But voltage V1, V2, V3 we can have here. The speciality of the parallel circuit is in parallel V will be equal to V1 equal to V2 equal to V3. Voltages will be remaining same, but current I will be equal to I1, I2 and I3. But according to Ohm's law, I is equal to what? V by R. If you substitute the value of I in the above equation, you will get V by R will be equal to V by R1 plus V by R2 plus V by R3. Here you can take V common and it will be cancelling from both the sides. Then I 1 by R will be equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus dash dash plus up to 1 by Rn. So now you can see, if the resistances are joined in parallel, this is the standard equation to calculate the equivalent resistance of that circuit by using this formula. So this is the parallel combination. Supposing that if two resistances only they are connected in parallel. If two resistances they are connected in parallel, what will be the total resistance? Total resistance R will be equal to R1 into R2 divided by R1 plus R2. If two resistances they are in parallel, product of 2 divided by sum of the same you can utilize. And in the second, if three resistances they are joined in parallel, then the total resistance R will be equal to multiple of all the three resistances divided by product of 2 at a time. R1 R2 plus R2 R3 plus R3 R1. So if 3 are connected in parallel, you can use this formula. If 4 are connected, then in the numerator you will get R1, R2, R3, R4, and here in the denominator, product of the 3 at a time you will get it. Suppose that equal value of resistances are joined in parallel, then what is the total resistance of the circuit? Equal value means suppose that 20, 20, 20 connected 20 times, or 100, 100, 100 connected 100 times. In that case, how you are going to calculate the resistance? So you can write here value of one of the resistances divided by number of branches. Suppose that 100 ohm is connected 100 times. Then what is the value? 1 ohm. So normally, suppose that if this technique is not known, how much paper is required, how much time is required to calculate that resistance for the 100 ohm connected in the 100 times, it will be too much. So that's why the short technique for calculating the resistances if they are connected in parallel is to be carried out like this.